Hello everyone! In this video, I will be covering the Amplify unit, the Earth System for 5th grade. I am Jessica, and I teach 5th grade science in San Jose, California. In this unit, students will take on the role of water resource engineers to answer the question, what can determine how much water is available for human use? Before we begin, make sure you have read and annotated the unit overview, unit at a glance, and standards, that you have read and annotated the science background knowledge, that you print out the unit internalization guide and get a pencil ready. Pause the video if you need a moment to get your materials. So why does this unit matter? Water on Earth is an invaluable resource. This unit brings student attention to the reality of freshwater availability, what causes water shortages, ways that we can alleviate the effects of water shortages, and closing the unit with trying to solve a water shortage problem. Now we are going to take a deep dive into each chapter and the content that will be covered in the Earth system. As water resource engineers, students will be investigating a fictional scenario on Ferris Island. Students will discover that even though they are on the same island, East Ferris is facing a water shortage, while West Ferris is not. In Chapter 1, students will be answering the question, why is East Ferris running out of water while West Ferris is not? At the beginning of each chapter, students will receive an email from the mayor of East Ferris. Each letter outlines the chapter problem and question that students will be working to answer. In this first chapter, students will also be reading 2 books. The Water Encyclopedia, which will be referenced throughout the entire unit and a great go-to resource for students as they are learning about water on Earth. The second, Water Shortages and Water Solutions, gives students background information about water shortages as well as human impact. In this chapter, students will also be asked to analyze graphs as they relate to water availability on Earth. You will see that this unit is unique in the way chapter tasks are laid out. There is no Chapter 1 task. Take a look at the key takeaways that students should have at the end of Chapter 1. Pause the video if you need a moment to read. The Chapter 2 question is, why does more rain form over West Ferris than East Ferris? The progress build that we are working towards in this chapter is that rain can happen when water vapor cools and condenses into liquid water. The chapter starts off with another letter from the mayor, laying out the chapter question and dives straight into hands-on experiments to help students understand how condensation happens. In this chapter, students also get introduced to the sim. The sim is a great resource used through the rest of the unit. This is a screenshot of the sim that shows what students can do. They can simulate wind and rain, they can track single water molecules throughout the duration of the sim, they can see temperature as it relates to height in the atmosphere, and they can evaluate the number of liquid and vapor molecules in a specified area. This chapter focuses on the water cycle and how temperature affects how water molecules move and change. Additionally, the book Drinking Cleopatra's Tears walks students through the water cycle and the idea that the water they use today has been around for millions of years. They might even be drinking dino pee. The reaction when students hear that is great. In the final lessons of the chapter, students get another letter from the mayor. They are challenged with the task to design their own freshwater system that will take salty water and turn it into clean fresh water. They are walked through the design process to assist them as they begin work on their projects. Now that students have had time to brainstorm and design their projects, they get to start building. These are a couple designs that I have seen. I love seeing the students' unique ideas and creativity here. Granted, some of the designs will not work, and that's okay. Following their projects, students will finish this chapter reading the book Engineering Clean Water, which is a great reflection tool after the project has been completed. Students will finish off this chapter by taking a critical juncture assessment. Within this assessment is the written response for Progress Build 1. The question is, Jesse is looking at the picture of Ferris Island. He is wondering why it rains a lot in West Ferris, Using what you've learned about how water travels, explain to Jessie why West Ferris gets more rain. Take a moment to pause the video and answer the question for yourself. Okay, task 1 is complete. Take a look at the exemplar response. Pause the video to see how you did. Now we are moving on to Chapter 3. The Chapter 3 question is, why is more water vapor getting cold over West Ferris than East Ferris? The progress build we are looking for in this chapter is that water vapor condenses as it moves higher to where the atmosphere is colder. At the beginning of Chapter 3, students are presented with, yes, another letter. We are also diving straight into hands-on activities this time, creating not only condensation, but precipitation as well. Students will return to the sim to investigate water vapor and how temperature affects the amount of water in the air. We are also returning to the water encyclopedia to learn about the interaction between the atmosphere and the hydrosphere. And we have arrived at the chapter task already. Yes, this is a short chapter. This chapter task is split into 2 days. Students are presented with a claim and they need to decide if they agree or disagree after completing an investigation of their own. The claim is this. The Ferris Island Chronicle, a local newspaper, recently wrote an article explaining why it does not rain in East Ferris. The newspaper claims that East Ferris does not get a lot of rain because the clouds stop at the top of the mountain. On day 1, students will be collecting data in the sim and graphing the data they collect. Take a moment to pause the video and take part 1 of the task on your own. Okay, let's see how you did. Keep in mind, the data will look different for each student, but the trends will be on par with this exemplar. We should be seeing that as the air temperature decreases, the number of water vapor molecules decreases and the number of liquid water molecules increases. Now it's time for day 2 of the task. Again, students are looking at the same question, but now students need to use their data to create a constructed response, agreeing or disagreeing with the newspaper's claim. If you have not done so already, take part 2 of this task on your own, and remember to use data to support your answer. And here is an example of an exemplar response. What we are looking for is that students disagree with the newspaper's claim and are able to explain the relationship between air temperature and water molecules. And now we move to Chapter 4. The Chapter 4 question is, why is there more water vapor high up over West Ferris than East Ferris? Again, this is a short chapter, so be prepared. Taking a look at Progress Build 3, it asks students to recognize that mountains can redirect water vapor higher in the atmosphere. The main goal of this chapter is that students understand what rain shadow is. This includes a complete understanding of the full water cycle and the fact that the rain shadow effect is what causes East Ferris to get less rain. Students will be completing a sim investigation to help them understand this concept. Students will also be reflecting on their freshwater designs before completing the chapter task. What did I tell you? It is a short chapter. We have arrived at the Chapter 4 task. This is really a chance for students to use what they have learned to reflect on their freshwater systems and to evaluate 2 different freshwater system designs. The question is this. John and Maria have both created a freshwater system. Both John and Maria think that their freshwater system will collect more fresh water. Students need to decide whose system will collect the most fresh water. Take a moment to try this task for yourself. Pause the video and take task 4. All right, here's an exemplar for the Chapter 4 task. We are looking for students to claim that Maria's system will collect more water, ultimately because she has a separate freshwater collection container. Students should be using the entire water cycle process in their response. Okay, we've made it to the last chapter in the Earth system, and that is Chapter 5, Chemical Reactions. The Chapter 5 question is, How can East Ferris turn wastewater into clean fresh water? Note that there is no progress build for this chapter. And there it is, another letter from the mayor outlining the question for this chapter. In this chapter, students will discover how wastewater treatment plants work. And that's, yes, through chemical reactions. Students get to do a really great activity to investigate chemical reactions called the hot yellow gas reaction. After this intro lesson, they will read Chemical Reactions Everywhere, which talks about many different chemical reactions, as well as ways to identify a chemical reaction versus a physical reaction. In this chapter, students will revisit the nanoscale for a close-up look at how molecules get rearranged after a chemical reaction, and revisit the hot yellow gas reaction to identify exactly which substances are responsible for each part of the reaction. The Chapter 5 tasks ask students to explain chemical reactions based on what they have learned. In this task, students are informed that Mayor McKnight does not want a water treatment plant in East Ferris. They are asked to write a letter to Mayor McKnight to explain why a wastewater treatment plant could benefit East Ferris. They are also asked to draw a model of what is happening at the nanoscale to better clarify their thinking. It's time to try this task for yourself. Pause the video and take Chapter 5 task. Okay, take a moment to compare your response to the exemplar. We should be looking for students to identify that during a chemical reaction, new substances are formed by the rearrangement of molecules, and this process is how wastewater treatment plants work. And take a look at the exemplar model. We are really looking to ensure that students have the same number of molecules throughout the entire model. This solidifies their understanding of conservation of matter when talking about chemical reactions. And now we've reached the end of the unit. Please make sure you have the end of unit test on hand. Pause the video if you need to. Starting with Progress Build 1, the question asks, on a summer day, water particles from the ocean change phase as they move into the air. Which model shows this change? And the answer is D. Progress Build 1 wants students to understand that when water molecules get warm, they spread apart and turn into water vapor. Progress Build 2 questions look like this. Use a model to help you answer the question, which model best represents what the molecules of water look like at location B? And the answer is A. Progress Build 2 wants students to understand that not only is condensation happening at location B, but condensation means that the water vapor is turning back into liquid water. And Progress Build 3, the question asks, using the map as well as what has been taught in class, why does Tibet receive less rainfall than Nepal? Did you identify and describe rain shadow? If so, then you got it. Pause the video and take a look at this exemplar. And here's another constructed response on the assessment. It asks students to use the table to identify the season when you would see the least amount of groundwater in Worcester. Try it on your own and make sure to use data from this table to explain your reasoning. Did you choose wintertime because the data shows that winter has the least amount of precipitation and therefore the least amount of groundwater? If so, then you got it. Pause the video and take a look at this exemplar response. Thank you, teachers, first of all, for all you do for our students. You make a difference. Thank you for taking the time to work through this unit. It is a great unit and students will love the hands-on learning experiences throughout the unit. I hope you and your students enjoy the Earth system. Happy teaching! Final steps for KIPP teachers. Please make sure that you finish taking the entire end of unit test, that you complete your unit internalization guide, that you submit the unit Google form on kipc.org, that you calendar out your unit, that you prepare vocabulary and anchor charts, that you organize your kit and materials, and start prepping and rehearsing your lessons.